Welcome to CEC lectures. Myself Dr. Priti Jagwani from Department of Computer Science, Arabhat College, University of Delhi. So in this series of computer networks, in my last lecture I have taught you about various networking devices. So we started with what all these networking devices are, what are the functions of different networking devices, and we have covered in detail about the access point, modem, RJ45 and NIC. But the list is not, that's it, we are left with so many networking devices to be covered. So let us begin with our next networking device, which is a repeater. So when we say repeater, the name indicates that it is to kind of repeat, or one who repeats, we can say. So when we say repeating the function or repeating the signal, or we can say regenerating the signal, that means we are actually amplifying the signal. So the main function of the repeater is to amplify, or we can say regenerate the signal over the same network before the signal becomes too weak or corrupted to extend the length to which the signal can be transmitted over the same network. So for example, we have a network which is kind of expanded enough, and we want to kind of send signal from one place to one sender end to the receiver end. That is the basic very basic of a network. So now for example, over the over the length or over the period of time, we can say while transferring this signal will definitely become weak, or it could get corrupted. So what do we need to do? We need to amplify, and we need to repeat, or we need to regenerate the signal, obviously over the same network. So this is what the function of your repeater is. So it is a device whose main function is to amplify. Now whenever we talk about repeater, we always say that operates at the physical layer. Now what is this physical layer? In our upcoming lectures, we will be definitely talking about different models of the network, or protocol layers. So basically these network model operate into in different layers, and the lowest layer of any network where one machine is actually connected to the another is physical layer. So repeater operates at the physical layer. Now this is actually a two-port device, and I hope you understand what actually a two-port device is. Now what happens, what is the strategy, how this or what is the kind of implementation level details if we talk about. So when the signals become weak by kind of we can say transmitting over the network, they copy it, that means the repeater copy it bit by bit and regenerate it at its kind of we can say connector. So for example, star topology we talked about. So star topology connectors which are connecting, we have connecting the different nodes. So in this way, when the signals is becoming weak and they are kind of regenerated bit by bit, that means the original strength is kind of regained again. Also a repeater is responsible, as I have told you, it is responsible for amplifying the signals. It is also responsible for rebroadcasting the incoming signal to extend their reach and making them more usable. So basically what by by this extending the reach of the signals, or by rebroadcasting the incoming signals, the repeaters have done the task of increasing the network's reach. They have also restored the damaged, or we can say the weak signals, and provide access to the nodes that are otherwise inaccessible, because at the nooks and corners where your signals are not able to reach, we can have amplifiers in between, we can have repeaters in between whose job is to kind of amplify, and then we will be able to reach to the devices, or we will be able to reach to the nodes who are otherwise inaccessible. Now what kind of range of transmission types these repeaters support? So if we talk about the range of transmission, they support a wide variety including analog, digital, light based transmission. So we can say yes, they are a versatile and essential component of modern network infrastructure, because nowadays it's important to extend the reach of a network. And also they operate, how they operate by magnifying the received signal to a higher frequency domain, also making it more scalable, making it more accessible, and making it more suitable for the transmission. So, this was the job of repeaters. Now, please recall, when we started with these networking devices, one job or one function of these network devices which we were talking about was to provide security to the network by controlling the access. And this is the key line of our next networking device, which is a firewall. So, firewall actually is a critical network security device that acts as a sentinel. The job is to monitor and control all the incoming and outgoing network traffic in order to ensure that only authorized traffic is allowed to pass through. So, I repeat, it is a critical network security device that acts as a sentinel. The job is to monitor and control all incoming and outgoing network traffic in order to ensure that only authorized traffic is allowed to pass through. So, that means by ensuring this authorization, this networking device firewall is going to help us in making the network secure. Obviously, this is actually, if we talk about network security, your firewall is a kind of, we can say, first line of defense, a very crucial component. It also serves as a barrier between trusted internal networks and untrusted outside networks, for example, internet. So, whatever traffic is coming from the internet or whatever traffic is going onto the internet, and on the other side there is an kind of intranet of a particular company, we need to establish a firewall in between, who is kind of going to monitor what all traffic is being passed through from one end to another. For example, within an institutional network, we don't want the students, or we don't want the users to access social media. So, all those kind of, we can say, sites can be blocked, and firewall is going to help us there. So, firewall, when we include this firewall inside our, or in the list of our networking devices, so firewall, you can say, it could be a hardware based solution, it can take various forms. So, it could be a hardware based solution, it could be a software based solution, and nowadays with kind of moving technologies, it could be a cloud based option, which can be kind of, we can say, obtained as a SaaS. SaaS is software as a service, SaaS. So, if it is a software which is available on the cloud, it could be a software which is available at your own end, or even it could be in the form of a hardware setup. And if I am if I want to elaborate cloud, if we see, that could be a public cloud, or kind of a private cloud also. So, firewall, yes, a first line of we can say defense, and which is there to authorize the traffic incoming as well as outgoing both. Moving further in the list, we have routers. Routers, as the name indicates, the job is, or we can say, one who kind of routes. So, this is a networking device which connects multiple packet switched networks, or we can say multiple sub networks. Now, what is packet switched networks? Please hold on for some time, we will be kind of going to describe this soon in our upcoming lectures. So, as of now, we can say, so in order to connect multiple sub networks, we can use routers. So, basically two primary functions are there for the router, that is, first is the kind of managing the traffic between the networks by forwarding the data to their intended IP address. That means this is going to kind of, we can say, route the data packets to their kind of destination or intended IP address, and also it allows multiple devices to share the same internet connection. So, two functions, I repeat here. One is to manage the traffic between the networks, another one is to allow multiple devices to share the same internet connection. Now, router basically can be used to transmit data from one local area network to another if these both supports same set of protocols. If there are two networks which are working on kind of which are supporting different protocols, then you cannot use the router to transmit the data between these two, because router transmits the data between the two lengths if these networks supports the same set of protocols. So, typically we can say router can be connected to the two local area networks and the internet service providers. It receives the data in the form of packets. Packets, you can say, is kind of a small bundle of the data, which are data frames with their destination address added. So, these packets have their destination address inbuilt in them, and the job of the router is to kind of we can say push all those packets onto the correct path, because the job is to kind of route the data. So, basically a device we can say that routes the data packets based on the IP addresses which on which layer this is going to operate. As in the previous device which was repeater, I told you that this is going to operate on the physical layer, which is the we can say lowermost layer. This operates on the third layer, which is kind of which is more commonly known as a network layer. So, yes, we can say that router is mainly a network layer device. Not only it is used to connect the two LANs, it can also connect the LANs and WANs. And one important component of the router is the routing table. So, that routing table has to be kind of updated. The routing table is having all those routes coded into that, and based on this data, router is going to make decisions of routing different data packets onto different paths. The router divides the broadcast domains of host connected through it. We can also see that see this in this manner. Typically, if we talk about these routers, serves as a kind of bridging component between local area network and wide area network. Wide area network and local area network are these two common terms which you are aware with. LAN, a group of connected devices, restricted geographical area, and if we want to connect different devices onto that LAN, they typically require a single router. Wide area network, obviously large, span over a vast geographical area and requires multiple routers because of its distributed nature. So, for example, WAN, we talk about any large organization or company with multiple locations across the country, and separate LANs are there for each location to form a cohesive network. In these type of setups, your routers are kind of very important. So, routers, if we talk about, they can be seen as either the static or dynamic, depending upon how they are being configured. So, if it is a static router, they have to be configured manually and will remain static unless someone changes them. Dynamic router, if I talk about, will use the data from nearby routers to inform their routing tables. That means they change their routing tables on the go, we can say, or dynamically we can say. Next component, moving on to the next one, is a hub. Hub, you can say it is having different names. It is also known as an active hub because of the nature of the task it performs, or it can also be called as a repeater hub. This hub, basically it is a network device that connects multiple computer networking devices together in order to create a single network segment. So basically it has multiple input output ports where a signal introduced at any port is echoed, is actually we can say copied to every other port except to the original one on which it is coming, because then there is no point in kind of echoing, or no point of sending it back on this original incoming port. So with this multiple input output ports, a signal is introduced, a signal which is kind of introduced or which is received at any port is given to all other we can say it's echoed to all other ports except obviously the original one. The same question again here also. Repeaters operates on the physical layer, routers operates on the network layer. What about hub? Hub also operates on the physical layer. It also works by amplifying and retransmitting the incoming signals. Now some hubs may also include some additional connector. What kind of additional connectors are BNCs we have seen in our previous lectures, or AUI, and these, because of these connectors, some legacy network segments which are 10/2 or 10/5 cables will be able to kind of get connected to the network. Now these hubs, if I am talking about, they are largely obsolete and they are being replaced by network switches in most of the cases, except in some specialized installation. Nobody uses these hubs nowadays. Switches are more into we can say more into usage. In fact, the use of repeaters or hub to connect the network segment is actually deprecated by IEEE 802.3 standard early way back in 2011. So use of repeaters as well as hub in order to connect the network segments, not for the kind of repetition of signals. If they are being used to connect to network segments, that usage is deprecated in the standard IEEE 802.3. Now if we talk about the types of hubs, there are two types of hubs. One can be a simple hub, another one is a multi-port hub. So two types here. Simple hub is only one port for connecting a device to other networks. Second is multiple port hubs. So there are multiple ports in this, and a user can connect to many devices, some of which expand maybe in a modular fashion. So if you want to connect more devices, you can use multiple port hubs, or you can use simple hubs if you want to connect a device to other, if you want to connect one device to other networks. Now you can also see that hub as a multi-port repeater, and hub can connect multiple wires coming from different branches. For example, please recall the structure of the star topology, in which there is a kind of central connector in central connector to which different stations are being connected. So that central connector could be a hub, but hubs are not going to filter the data. So the data packets are sent to all the connected devices. That means hubs are not going to look into the incoming data packets in order to see that whether on which particular line these should be replicated and on which particular lines these should not be echoed. So that kind of filter is not available with hubs, and also they do not have intelligence to find out which path is best for data packet in order to kind of have an efficient delivery, and in order to minimize the wastage. They are not intelligent enough in order to kind of look into all these nitty-gritties. Also they cannot we can say filter the data. Now as far as the structure are concerned, we have seen a simple hub or a multi-port hub. But if we look into the types of hub, we have three different types of hubs. When we have active hubs, we have passive hubs, and we have intelligent hubs also. So active hub, if we talk about, so these are the hubs that have their power supply and they can clean, boost and relay the signal along with the network. That means they are serving both as a repeater as well as a wiring center, and they are also used because repeater, when we talk about, that means they also used to extend the maximum distance between the nodes. So they can have their own power supply and they can clean or boost or relay the signals. So these types of hubs are known as active hubs. Moving on to passive hubs, these can collect the wiring from nodes and power supply from the active hubs. These hubs relay signals onto the network without cleaning, without boosting them, and they cannot be used to extend the distance between the nodes. So, cleaning the signal and then relaying it, boosting the signal and then relaying it, and also extending the distance between the nodes are actually properties of active hubs. So, another criteria or another category of hubs is the intelligent hub. Some kind of slides before, some minutes before, I have told you that intelligence is not a built-in kind of, we can say, feature of hub. Now, one variety of hubs can be something if they are made intelligent. That means some kind of remote management capabilities are being introduced in an active hub. That means it works like an active hub, and it is going to kind of relay the signals after boosting and cleaning them, and also includes some remote management capabilities. They can provide some flexible data rates to the network devices, or we can say it also enables an administrator to monitor the traffic passing through the hub and to configure each port in the hub. If all these capabilities are kind of, we can say, introduced in an hub, then we cannot say that then we will be not in a situation to say that hub is a non-intelligent device. Then your hub certainly becomes an intelligent device. Moving further, the next networking device is bridge that operates on the data link layer, which is the layer between the network layer and the physical layer. It is, we can say, it's also kind of a repeater. It repeats, but it is having an add-on functionality of filtering the content by reading the MAC address. MAC address, please recall that MAC address is encoded on the NIC card. So MAC address of the source and the destination. So that means it will filter the content, that where it should kind of where it should be echoed, where it should not be echoed. It is also used for interconnecting the two local area networks which are working on the same protocols. So it typically connects the multiple network segments, and each port is connected to different segment. If we talk about bridge, it is not strictly limited to 2 ports. It can have multiple ports, and modern multi-port bridges are often serve as layer 2 switches because they perform similar functions. So, if we talk about the types of these bridges, as I have told you, that operates on the data link layer, and they are having an add-on functionality of filtering the content along with being an repeater. So, the types here are the transparent bridges, the bridges in which the stations are completely unaware of the bridge's existence, that whether or not the bridge is added or deleted from a network, reconfiguration of the station is unnecessary, it is not required. So, that means if you want to add them or even if you want to delete them, the whole network will kind of will not be affected, I can say. So, transparent bridges, these bridges make the use of 2 processes, one is bridge forwarding and another one is bridge learning. Apart from transparent bridges, we have source routing bridges. In these type of bridges, routing operation is performed by the source station, and the frame specifies which route is to be, that data frame specifies which route is to be kind of follows. So, source routing bridges are there. They enable multiple communication network or network segments to be combined into a single unified network. This process is known as network bridging, which is obviously kind of, we can say, different from routing. So, while routing allows multiple networks to communicate independently while remaining separate, bridging connects the two separate networks as if they are kind of a single entity, and this is what the difference between your bridge and router is. In OSI model, bridging occurs at data link layer, which is layer 2, as I have told you. Moving further, we have switch, which is a network device that connect other devices to Ethernet network through that twisted pair cables, and twisted pair cables we have already covered in our previous lectures when we learned about transmission media. And this switch maintains a list of network addresses of all the device connected to it, and hence it will forward the data packets onto the network. So, we can say the switch is kind of a multi-port bridge with a buffer designed into that, a storage area designed into it in order to boost the efficiency. Again, your switch is also kind of a data link layer device, and it can also perform one important functionality. The switch can also perform error checking before forwarding the data, which makes it very efficient, as it is not going to forward any data packets having the any error. It will forward also only the packets which are kind of we can say error free, and it will forward to the correct port only. There are so many types of switch, we can say unmanaged, managed, smart switches, layer 2 switches, layer 3 switches, then power over Ethernet switches, gigabit, because of the speed we call them as gigabit switches, rack mounted or desktop switches, or even modular switches. These are different types of switches. If you want to go into details, you can find this in any standard book of computer networks. So, let me summarize the lecture. We have started with various networking devices. We looked into repeaters, firewalls, then routers we studied, and also we studied hub bridge switches along with their different functionalities. Here is a list of references which is being used for the preparation of lecture. I will see you in the next one. Till then, take care. Goodbye.